Okay.
The recording is started. Yeah.
I started. Okay, good.
So
Okay.
Okay,
may
so
start
it will be
your
my
I
turn
think.
now.
Mhm.
Then let me share my screen. And let me start right away.
Okay.
This is mostly about what we eat and what that does in our body. So especially addressing European culture, North American culture, what do we eat? And there is a lot of so-called junk food around, which mostly consists of carbohydrates and fat. And we have to look into what that does in our bodies. And we all know what we should eat. There is no point in telling everybody. But we would have to look into what that does and why is it so important to eat protein and essential fats and vitamins and minerals and so on. So why do we do that? And for the first thing is we look into what carbs are, how they are processed, and what this has to do with diabetes. And this is a gimmick for the pharmacist. This is glucose, and for the rest of this talk, we won't use those formulas. I just want to alert you to this one detail here. All these carbon atoms, 3 or 4 of them, they have one hydrogen and one OH group, which together is H2, the two hydrogens, one oxygen, like in water. And so that is what gives the name carbohydrate, as if the carbs are immersed in water. So from there you get the name. And from here on, I will just use the blocks. That's all. And having many of them together, chained together, this is starch. And that is a nice thing of these glucose molecules. They can chain, they can hook up to each other and build long chains. And that is what we have in potatoes and rice and all these foods that are called carbs, carbohydrate foods. And in the body, in the intestine, these individual glucose molecules are clipped from the long chain, and that takes some time. So we won't have them all together. This is what digestion actually does then. There is another so-called sugar, which is fructose, fruit sugar. And the name might suggest that it is healthy because it's from fruits. But no, it is not that healthy. This fructose it tastes a little bit sweet. It does not contribute to glucose level in the body, obviously, but it is bad for the liver and it results directly in fat. The sugar that we put into our coffee is a connection between glucose and fructose. So it is half of it is damaging directly, and the other half is damaging indirectly. So you will see after this talk that all kinds of eating glucose in a way that makes it available to the body right away in big amounts is not good. And having a dimer here, putting together a conjunction of 2 of these things, it is easily split. So it is whatever we eat in terms of sugar is glucose in the body right away in one big shot. We have to talk about the pancreas. Now look at this schematic diagram. There is the stomach, and the liver is in front of it. The liver, appended to the liver is the gallbladder, and somewhat behind the stomach is this organ called pancreas. And right in this curve, it ends in this curve where the stomach goes into the small intestine. This pancreas' main duty is to produce enzymes that do that digestion, clipping those starch molecules apart. And this this pancreas contains those so-called islets of Langerhans, those little areas in which we find B cells. And we want to look into their role because that's what does the work with insulin. And in front of all that, well, the small intestine continues from here. It is convoluted here. And in front of all that is the large intestine. And now if we eat starch, it goes into the stomach, it goes into the small intestine, and the pancreas has secreted its enzymes. So the starch is clipped into the individual glucose molecules, not in one big go, but as the food passes along that intestine, more and more glucose molecules are clipped from the starch molecules. So they end up in the blood. And this blood passes again through the whole body and passes by those B cells, and the B cells release insulin. So they measure the concentration of glucose and they release insulin. And the insulin tells the muscles to absorb the glucose from the blood. So it goes into the muscles and the muscles can generate their energy from it. Also, the fat cells read that signal. They are triggered by insulin to consume glucose and they build fat from that. And now we have a basic level of glucose left that is necessary. You can't go to zero and everything is fine. However, there are diseases that diminish B cells and what B cells can do. So the one that directly kills B cells is diabetes 1. It origins in the fact that in some people, unfortunately, the body kills its own B cells. So with no B cells, you don't have any insulin, and the glucose just accumulates in the blood. And muscles and fat cells are starving. So there are not so many fat cells. Muscles are using fat from the food, and the brain is a little bit starving. And but that is all not what we really feel. Diabetes is a disease that does not really really make us unhappy in the first moment. We don't even feel that we do have diabetes. But in the long term, glucose damages the walls of the blood vessels. And with this long-term effect, if vessels are damaged, and those are the small vessels that are damaged. So in some people who have diabetes for a long time, the vessels in the eyes are damaged, so they are blind. And in other people, it's the vessels in the kidneys, so have kidney failure. Or the vessels in the legs, so they have to have their legs amputated. Those are long-term effects of diabetes, and that's why it's so dangerous. Okay, this is the one type, and usually if it starts in the youth. The other type is a little bit more complicated. See, if we have more fat, this fat, well, the first thing is it reacts like usual and you have the insulin, but now fat sends a signal to the muscles that it should not listen to the insulin. So glucose is not absorbed into the muscle. And the B cells have to produce more and more and more insulin to overcome that effect so that glucose can still be absorbed into the muscle. So the first effect is the strain on the B cells. They have to produce more insulin. Also, the same happens within the fatty tissue. It also inhibits its own response, so it cannot absorb glucose. Now, if we have even more fat, the effect is double. So these cells have to produce even more insulin. And glucose accumulates. More fat, and the B cells are exhausted. So now we get all the big accumulation, and we do get the damage to the blood vessels. Fortunately, this type of diabetes is reversible. And yes, it reacts to weight loss. You can reduce the effect on the muscles and on the other fat cells, and you can reduce the strain on the B cells, and thereby also the concentration of glucose in the blood is diminished, and all is going back to normal. It takes a while to repair the damage that has already been done to the blood vessels, but also that can be done. So simple weight loss, well, simple in quotation marks, I know, but weight loss is the best cure for diabetes type 2. Some medications try to mimic the effects, but is only mimicking and is not a real long-term thing. The best and most natural long-term remedy against diabetes 2 is weight loss. Okay, this is about carbs and diabetes. Now we have to talk about fats. There are good fats and bad fats, and what's the difference in those? Again, a formula, saturated fatty acid. It's just a long chain of carbons with hydrogens. And there is some head to this chain, which makes it an acid. Just a long chain. And, well, chemists are really lazy. They don't want to write those letters. They just draw a line, which is a zigzag line here. And that also reflects the structure of a fatty acid a little bit better than this straight formula, because it is a little bit zigzag, not only in 2 dimensions, in 3 dimensions. So that is a fatty acid. And there is another molecule consisting of 3 carbons with some hooks on them called glycerin. And now these fatty acids can hook to that. And together that makes fat. So fat is a chemical, as a chemical term, it's always these fatty acids hooked to these glycerin. Well, and this is so-called saturated fat. We will see what that means. This is what you find in bacon. And they all fit nicely together, so they can be packed. And this is why this bacon, the fat in the bacon is solid. And it can fit nicely next to each other. Now, to the contrary, we can also have unsaturated fatty acids. So this is still a saturated one. What is the difference? If we look at these 2 hydrogens and take them away, these 2 carbons need 4 bonds each. So they have a double bond, so it's 4 bonds again. And we see there are 2 hydrogens on one side and there's nothing here. And so this is likely to bend. And this is what happens. With such a double bond, the whole thing gets a curve. And if you have more of them, it gets convoluted. And you can imagine that such things don't pack as easily. So they can rotate, and one is rotated, the other one not. So and this cannot be packed so good. Maybe one of the compositions is that way, the other is that way. And this is what is in olive oil. This is fluid, and just because these fats cannot be packed as easily together. And then there is a very bad thing that can happen. If we have such a double bond, and this is a good one of a good fat, and we heat it, it can convert to this structure. And now this stabilizes. There is no reason for the molecule to have a bend. Instead, this cannot be rotated at all, so it stabilizes. It is extra flat, and these things can be packed extra. So you know, if you have lamb chops, the fat on lamb chops is really hard. And there you get the list. The best is the polyunsaturated omega-3. That means that this double bond, the last double bond of several ones, is 3 atoms from the end. So this would be an omega-3, 1, 2, 3, and there's the double bond. Those that the human body needs are longer. And they have 6 bands, only the last one is 3 positions from the end. And where do we find them? We find them in flax seeds, and we find them in fish. So Leinöl, it has short omega-3 fatty acids, and fish have long ones. They need to be fish from cold water, from the Arctic Ocean, because for the fish, that is their protection against the cold. So what the body needs are those long ones that are in the fish. It can produce long ones from the short ones from Leinöl. I have looked up the word. And then it can produce them, but it needs some long ones to start with. So you need some long omega-3 fatty acids, or better fats, long omega-3 fats from fish. Good is the simple unsaturated, as in olive oil. And still, you should not heat these. You shouldn't heat this at all. This should be kept in the refrigerator. This can be kept as usual, but if you heat it in the pan, in the frying pan, don't heat it much. Just now, better not. It is said that olive oil is good for baking, but don't heat it as such that it smokes, and much less than that. Neutral and the best thing to cook and fry for the frying pan is oil from coconuts. This is saturated but short, and it's as a nutrient. It is not the best nutrient, but it's the best thing to cook with for the frying pan, because it does not convert into the very bad trans fats. Bad is the saturated long, like in bacon, and very bad are those trans fats, which are even without heating, they are naturally in lamb and goat and cow, or the ruminants. So never ever eat fat from goats or lambs or so. You know, all the fats you eat, they are incorporated into the membranes in the body. They're incorporated into the inner linings of the vessels. So how do you want your blood vessels to look like inside? Do you want them flexible and smooth, or do you want them as hard as the fat on pork, on lamb chops? And this is your choice in what you eat. So the next chapter would be proteins. Let me just have a drink. Proteins also are long chains. They are chains of amino acids. And I've drawn here, I have a picture of lean meat. It can also be lean fish, or it can be tofu or something. It is important that we have those amino acids. And we need that a little bit for energy, but most we need up for the buildup of the body. Muscles consists of proteins, so that the body needs proteins and amino acids to build muscles, to build essentially all the tissues. And the body needs the amino acids to function. Especially the nervous system needs amino acids to produce its the molecules that transmit the signals. So if we don't eat enough proteins, well, we wouldn't build up anything. This is what the body can reduce. But it will consume its own muscles in order for the brain to function. So if you want to avoid using up your own muscles, then better eat proteins. And then we come to the groceries. And there in Africa, you really have an advantage. See, what I always tell the Europeans is humankind originated in Africa. The human body is evolutionary accustomed to the food in Africa. And what is in Africa, in most regions of Africa, everything grows all the time. At least in those regions where humankind originated, everything grows all the time. So you have ripe fruit. And now I think you know from your own experience, at least those of you who live in Europe here, if you buy bananas here or buy any of the fruits that you know from home, what does it taste here?
Oh my God. The taste is different.
Yes, you know the difference in taste.
Yes.
And this is not only the taste.
Mm.
Well, these are all the good things in the fruits. The fruits produce most of their ingredients, most of the things that human bodies need within the last 48 hours before they fall off the tree. But how do you get such fruits that have just fallen from the tree into a German supermarket? It will be rotten all the way, but there is no way to do that. So for fruits that can be bought in the European market, they have to be harvested long before they are ripe. And then they have a long transportation and long storage time where they already degrade what they have. They don't develop all the things, and what they have already degrades before you buy them. So, and in Africa, you have them. Especially if you have a big garden, you have them all the time. They're ripe and fresh. And I would love to live there if it wasn't so hot. If it wasn't so hot. It's too hot for me. Otherwise, have it ripe and fresh, and so many of them. So you have, if you really go and look for all the different things that you can buy in Europe, fruits and vegetables together, it's about 40 different things. I don't know. Well, I think I don't even know the names of all the things that you have there in Africa. It is such a diversity, ripe and fresh. You can go sit in your garden and eat. That is so. And we Europeans, what can we do? buying things from the supermarket, okay, they are not ripe and they're not fresh. So we don't get all the ingredients that we need, that the plants would produce directly before they are completely ripe. And so if we don't get the best thing, the thing that I recommend to, and what I take myself,